Hello everyone, welcome to this session, Kubernetes and MLOps for Scalable and Reproducible Generative AI Workflows. Very great topic, hopefully a very learning and educational filled topic as well, and amazing that everyone has decided to spend this bit of time on learning more about MLOps and related topics here today with me. So let's dive right in. What will this session actually be about? So we're going to be covering through a lot of the AI, MLOps, generative workflows and producibility, scalability topics here today. I'm hoping to give you an overview on a lot of the topics that you can then do a more deeper dive on your own as well. So hopefully this session will spark a lot of interest on your side on what to learn next, what to deep dive next, and hopefully I can introduce you a lot of new concepts or old concepts in a new way. Perfect, let's go. So who am I first? So I'm Annie Talvasto. Hi, nice to meet you all virtually here. I am CMO at Vision, and Vision is a Swiss company specializing with a DevOps as a service or DevOps enabler. So we offer both professional services around DevOps, Kubernetes, and OpenShift, as well as we have hosts of our own products such as a container platform, Apuyo, and so forth, and open source products particularly. But in addition to that, I'm also a CNCF ambassador as well as an Azure MVP. And what those two mean essentially is that I'm excited about all of these kind of cloud native and Kubernetes topics, and I love sharing and learning together with people in events such as this. And I'm also a Kubernetes and CNCF meetup co-organizer, as well as a startup coach, particularly for early stage startups. I've actually been a Kubernetes and CNCF meetup co-organizer for around over 5 years now, since 2017, for Finland in particular, and nowadays I help out with Switzerland as well. And I live in Zurich, but I am from Finland originally. I also co-host the Cloud Gossip podcast. I'm also been hosting the Cloud Native Live, which is a weekly show by CNCF for a few years now, as well as I am frequently in the KubeCon program committee as well, which is always an absolute joy. But that's a bit about me and my background, and you can see it's very cloud native, very Kubernetes focused background in general. But let's then dive more into the topic of today, into scalable and reproducible AI workflows. Perfect. So our agenda today, this is the introduction portion, so we're doing well here. Then we're going to go through some definitions. And now definitions aren't, in my opinion, always the most fun topic to be running through, but I think in particularly in this topic, which is very trendy, very topical, particularly, it's good to kind of set the expectation and definition so that we all know what we're actually talking about when we say these words and how the words actually intersect between each other and how they kind of work together and so forth. So we're going to go through them a bit. Then we're going to go through why AI and machine learning is different from a regular engineering, quote unquote, or like what makes AI and machine learning engineering different, and hence why what are, for example, some of the actions that you need to take when you are doing such engineering. Then we have Kubernetes and MLOps. So, okay, how do Kubernetes and machine learning operations and AI, and how do all of these fit together? So that's going to be the next topic then. Then we're going to be talking through a bit about Kubeflow, more about that obviously later. And then we're going to go through some best practices on what to do and what to think if you're running your own workflows in this manner. Then we're going to have some considerations because there's always a catch, but that's hopefully is going to be an important catch, and I hope everyone can learn together from it. And then we're going to have some wrap up as well as resources that everyone can use to tap into as well. So then we're going to go to the next slide, but actually before that, I wanted to make this a bit more fun and not just having this regular old agenda here. We have here a pirate map. You can see X marks the spot here as well, and you see the mountains, the palm trees, so many things that we have to walk through. So this is essentially the world that we're going to walk through to learn more about machine learning operations, Kubernetes, AI, all these fun topics. But we can't be just, walking alone in this map. We're going to a goal. So we have the goal of scalable and reproducible generative AI workflow as our treasure, so to say. So that's going to be the reward at the end of the map. And walking with us is this amazing little robot who's going to be traveling with us here, so that we walk through all of these obstacles or learnings or whatever you want to think about them. Perfect. Let's go. Introduction done. Well done, us. And let's hop on to the first one, which is the palm trees here. So what is actually AI? Very big topic nowadays, but what is it actually? So artificial intelligence, aka AI, refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. So it involves the development of computer systems and algorithms that can perform tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, solving complex problems, making decisions, and learning from experience as well. So a lot of things there. But then let's go on to the next tree and learn more about machine learning. So ML is a subfield of artificial intelligence, aka AI, that focuses on the development of algorithms and statistical models that enable computer systems to improve their performance in a specific task through learning from data without being explicitly programmed. So you see here some of the key things, how this differs, or what makes machine learning in particular unique in that sense. Because in essence, machine learning allows computers to identify patterns, make predictions, and learn from examples as well as experiences. So data is key, learning is key, all of this. Well, machine learning is already in the name. There we go, there we see. Then we can hop on to the next tree, and there we see data science. So data science, on the other hand, is a multidisciplinary field that uses various techniques, such as algorithms, processes, and systems, to extract insights and knowledge from data. So data science is heavily related to machine learning. Well, you saw that machine learning was an important part of, or data was an important part of machine learning. So definitely these go hand in hand. But interestingly, with the rise of machine learning and AI, data science jobs has actually gone a bit down, which is very fascinating. But it's probably because data science is a rather large, like, for example, data scientist is a rather large title. So then maybe companies prefer nowadays, for example, machine learning engineer or one of these titles instead. But it's interesting to see these trends and how these affect these things. Then we're going to the next one, and this is DevOps. So we are in a conference that has DevOps in its name. So I think everyone will be at least somewhat familiar with DevOps. So DevOps is short for development and operations, and is a set of practices, principles, and cultural philosophies that aim to improve and streamline collaboration between software development, dev, and IT operations, ops teams. So that's what we're doing. So there's a lot of benefits, a lot of set practices already in DevOps, because it's a relatively old field in the tech world, at least. So there's a lot of things there for sure. But then actually, the definition of DevOps is highly important in the context of our next definition, which is here. It's MLOps. So MLOps is short for machine learning operations, and it is a set of practices, principles, and tools that combine machine learning with the practices of DevOps. So here it is the key. So almost all DevOps practices can actually be applied to MLOps. So if you're thinking, how do I start with MLOps, for example? Well, you probably start with DevOps, because if you think about the hierarchy of things that you need to master to do, for example, MLOps, I would start with DevOps first, master those, get good at that, and then you can kind of add on the MLOps layers from there, because DevOps is a much older practice, which means that there's a wealth of knowledge that you can tap into from there. And then also on this side, you can kind of also think about MLOps, it's DevOps, but with data, because that's what sets machine learning apart from some of the other things. So you have data as well as the relearning, but a bit more about that later, but that's kind of simplification on this front. Then going to the next slide about where we move more with our little robot. And we're going to go to why AI/ML is different. So how do these differ? I kind of teased already there a bit about these things, but let's go. So differences we see here. So it is AI and machine learning are very data-centric in nature. So the quality and the quantity of the data significantly impacts the performance of models. So this means that ML and AI engineers need to focus on data collection, pre-processing, and feature engineering, which are not as central in traditional engineering than on the other hand. Model complexity is another one. So in regular engineering, systems are typically designed and built according to well-established principles and specifications. But in contrast, ML and AI models are complex and their behavior is learned from data. So engineers really must experiment with various model architectures, hyperparameters, and training data to optimize performance. Iterative development is a big one as well, because the development in ML and AI is highly iterative often. So engineers continually experiment, fine-tune models, and retrain them to achieve desired outcomes. And traditional engineering projects tend to have more predictable and linear development processes. Then we have scalability. So ML and AI solutions often require scalable infrastructure to handle large datasets and computational demands, hence why MLOps and this session, for example, being very important, as well as the Kubernetes side of things. More on that later again. But this may involve in distributed computing frameworks, GPU clusters, and cloud-based resources, hence cloud native. But traditional engineering might not have always the same scalability demands. Monitoring and adaptation is super important as well. So ML and AI systems require ongoing monitoring to detect issues like model drift, data quality changes, or shifts in user behavior. So engineers must build systems that can adapt to these changes in real time, whereas regular engineering systems may not need such dynamic adjustments as well. Testing and validation is super important as well, and different. In regular engineering, testing and validation can be based on established standards and specifications. In ML and AI engineering, on the other hand, testing often involves evaluating the model performance against specific metrics, and validation may require domain-specific expertise and may not have clear-cut pass or fail criteria, on the other hand. Explainability and bias is highly crucial in AI and ML world. So understanding why an AI model makes a particular decision is absolutely crucial, especially in critical applications or fields such as healthcare or finance, because these decisions have long-standing effects into the people that it affects. And you really need to address these with explainability and so forth, because these might not be as considered in traditional engineering. Rapid advancement is another one. So the field of AI and ML is really, really evolving fast. So you really need to be up to date with your new technique, libraries, and tools emerging regularly. It depends a bit on like the regular engineering side, which field that you're working on how fast improvements happen. But definitely in AI and ML, there's a lot of stuff happening constantly. Collaboration is key as well, which means that, AI and ML require a lot of interdisciplinary collaboration. So you need to have data scientists, software engineers, domain experts, and infrastructure engineers all working together, understanding each other's principles and what they need and best practices and priorities and so forth. So it might be a bit different from regular engineering on that front. Deployment challenges is another one. So deploying ML and AI models into production requires special considerations. So engineers really must ensure that models are served efficiently, can handle real-time requests, and integrate with existing systems, which is important. Cost is another big one. So ML and AI infrastructure can be costly because there's so much specialized hardware as well as cloud resources that might be needed. So these things have to be considered because we don't want any company to go bankrupt because of their costs that are associated with ML and AI in particular. Yeah, so those are some of the differences that we see between AI and ML, for example, and why you have to take some differences approach. Then we have a continuation from here. So like, how does it look like to go from research to practice in this field? Because actually most models, AI and machine learning models, so over 50% of them never make it into practice. So actually one of the biggest bottlenecks in the field is the production side of things. how to make it there, how to make it scale, because I said over 50% of the models never make it there, never actually have that impact and benefit that they would have if they were to, getting to production. And when you think about like in terms of time, the model and code development are just the first steps. And then that might take a few weeks or more, obviously, but that might take a few weeks. And then actually to get things into production, it might take months with a large team of developers, scientists, data engineers, DevOps people, and so forth working together. So you really do have to focus on into that production phase in addition to the model and code development phase. So there's a lot of things there to think about, like, for example, packaging up your application. Someone has to do, so packaging into a container workflow. Someone has to do it. And it's important because data scientists focus on a lot of different things than production. So data scientists usually, for example, work in Jupyter notebooks, and they might not consider the production needs because it might but then for production, it might have to be switched to microservices and so forth. So there's a lot to consider there. And then you also have to consider scaling out, so load balance and data partitions, model distribution, AutoML, and so forth, because data requires multiple things, not just load balancing, and you might have to think about all of these things. You have to think about tuning it, so parallelism, GPU support, query tuning, caching, because things might not be built for latency, and you have to think about it in this term. You have to think about instrumenting, so monitoring, logging, versioning, security. And this goes beyond the regular Kubernetes or container monitoring, because in addition to those, one must monitor the data as well, for example. Automating is super important. Everyone from DevOps field probably knows this, because we do not want to repeat things and do everything again and again. So we want to automate things, and we want to kind of be faster in this way as well. And then we can think about CI/CD workflows, rolling upgrades, A/B testing, and so forth. And very crucially, the whole team has to work together to really kind of make these changes and get to the next level and get to the production. Perfect. So we've covered a lot here as well. Getting back to our map and hopping into Kubernetes and MLOps. And as you can see, we went through some mountains. We're going to the modular palm trees and shark neck now. And actually the fun part, well, not the fun part, there's a skull coming up. We can take bets into which of these areas is the skull, which is the hard part, in my opinion. Well, not the hard part, the important part. That's the crucial part that if you get it wrong, you're definitely going to be in hot water for sure. But which is important, and obviously think about that part. But let's see where we end up there. So we're now here, and we're going to go through some Kubernetes and MLOps considerations. So why Kubernetes and MLOps work well together? Why am I speaking about MLOps and Kubernetes in particular? Well, there's a lot of things that Kubernetes bring forward to the production side, particularly of MLOps and AI, that help you then reach that scalability and reproducibility in particular this session, and what is our treasure for this session as well. So Kubernetes really gives you the base layer on building and going to production and working on all these things. And there's a lot of some other things like Kubeflow that builds on top of that base layer, but more on that later. But for now, we're going to talk a bit about portability as well as the other sides of why Kubernetes works really nicely here. So why portability? Because Kubernetes really provides a good and consistent and portable platform for running machine learning workloads. So machine learning models and their dependencies can be containerized using Docker, making them highly portable across different Kubernetes clusters and even various cloud providers or on-premise environments. So there's a lot of variety there. So you can really develop and test ML models in one environment and seamlessly deploy them in another without worrying about environmental specific issues. And portability also simplifies the process of migrating ML workloads to different cloud providers or scaling across hybrid and multi-cloud architectures. Customizability is a big one as well. So Kubernetes is highly customizable, allowing you to tailor the infrastructure into your specific machine learning needs. So you can really configure your resources, networking storage, and security settings to match the requirement of your machine learning workloads. Performance is a big one as well. But before that, actually, like customizability, some of the benefits are that customization enables fine-grained control over resource allocation, ensuring that ML models receive the appropriate amount of CPU and GPU. And you can really then kind of set up custom environments and configurations for different stages of the ML workflow, from development and testing to production and deployment as well. But as I said, performance is a big thing. Everyone, if you're familiar with Kubernetes, you know how important performance is and how big it is in Kubernetes space. So It really offers performance benefits through efficient resource management, scaling, and load balancing. It ensures that machine learning applications can scale horizontally to handle high demand scenarios and efficiently allocate them the resources for optimal performance. And this means that like Kubernetes horizontal pod auto scaling, for example, allows machine learning workflows to automatically adapt to varying levels of demand, maintaining responsiveness. And efficient resource management minimizes the research contention, ensuring that then the models receive the necessary compute resources to perform optimally. Consistency is another big one. So Kubernetes really enforces consistency by providing a standardized and consistent environment for running ML workflows. So containers encapsulate the entire application stack, ensuring that the same code and dependency used for model deployment are used for during deployment. So a lot of the benefits are consistency, simplifying the reproducibility of ML experiment and results, reducing the risk of disparities between development and production environments. And you can then really rely on consistent platform for model training, serving and monitoring, and improving operational stability. Microservices is an important one as well. So Kubernetes supports microservices architecture, enabling you to break down ML applications into smaller, independently deployable components. So each component can be containerized and managed as a separate Kubernetes service or pod. So microservices promote modularity and flexibility in ML workflows, making it easier to update and scale individual components without affecting the entire application. And you can really build complex ML pipelines by composing and orchestrating microservices as building blocks, enhancing the flexibility and the maintainability then on the front end. But then we have composability as well, which is the last one on here. So Kubernetes allows you to compose and orchestrate machine learning components and services from end-to-end machine learning workflows. You can design complex workflows using Kubernetes native tools like Kubeflow pipelines. And composability simplifies the creation of reusable ML workflows. You can define, share, and reproduce ML workflows code, enhancing collaboration efficiency. And by composing ML workflows in Kubernetes, you can really easily integrate various components like data preprocessing, model training, as well as model deployment in the cohesive pipeline. So you saw there, I was briefly talking about Kubeflow there as well, so you can really use it. So luckily for you, we have next up the pirate map again, and we're going to be moving. There we go. We're going to actually go to the palms tree now from the shark and talk about Kubeflow. So Kubeflow is a machine learning toolkit for Kubernetes. So it's an open source platform that's designed to make it easier to deploy, manage, and scale machine learning ML workloads on Kubernetes. So it provides a set of tools, frameworks, and best practices to streamline the development and deployment of machine learning models in a Kubernetes environment. It's part of the Linux Foundation and it's part of the CNCF Foundation, which is part of the Linux Foundation, and it's an incubating project level at the CNCF, so Cloud Native Computing Foundation. So what is Kubeflow then actually a bit more? So it provides end-to-end machine learning workflow. So Kubeflow offers a united platform that covers entire machine learning workflow from data preprocessing and model training to deployment as well as monitoring. So the cohesive ecosystem then reduces the complexity of managing different tools and components separately. Scalability and resource management is another one. So leveraging Kubernetes orchestration capabilities, Kubeflow enables the easy scaling of machine learning workloads and can dynamically allocate resources based on demand, optimizing hardware utilization and improving performance. There's also reproducibility and collaboration. So Kubeflow's infrastructure encourages best practice for reproducibility by capturing metadata, environment details, and code versions associated with each experiment. So it facilitates collaboration among data scientists and engineers and researchers, which I actually noted before is one of the, not challenges, but like different things that you really need to facilitate that collaboration really well in order to do good work there. A bit more deeper into Kubeflow. So Kubeflow also includes services to create and manage interactive Jupyter notebooks, so you can customize your notebook deployment and your compute resources to suit your data science needs. So you can experiment with your workflows locally and then deploy them to the cloud when you are actually ready to kind of get rolling. Then also Kubeflow provides TensorFlow model training. So Kubeflow provides custom TensorFlow training job operator that you can use to train your machine learning model. In particular, Kubeflow's job operator can handle distributed TensorFlow training jobs. And you can configure the training controller to use CPUs or GPUs and suit various cluster sizes as well. Kubeflow also helps with model serving, so it supports TensorFlow serving container to export trained TensorFlow models to Kubernetes. And Kubeflow is also integrated with Seldon Core, an open source platform for deploying machine learning models in Kubernetes, as well as a host of other services. And it also helps with pipelines. So Kubeflow Pipelines is a comprehensive solution for deploying and managing end-to-end machine learning workflows. You can use Kubeflow pipelines for rapid and reliable experimentation. So you can run, schedule, and compare runs and examine detailed reports on each run. And Kubeflow aims to have a multi-framework approach, so there's going to be a lot more enabled in the future as well. So here you can see a like machine learning workflows before Kubeflow. So you have the experimental phase. So you have to identify a problem and collect and analyze data, choose a machine learning algorithm and code your model, experiment with data and model training, and tune the model hyperparameters, and then iterate in tuning and training. And at the production phase, you have to transform data, train model, serve the model for online batch prediction, as well as monitor the model's performance, and then iterate tuning and training. So that's the way it goes. But how does it then look with Kubeflow? So with experimental phase, you have a lot more tooling there. So you have PyTorch, TensorFlow, and all of these Jupyter notebooks working there. And then you have production phase, so you have a host of there as well. So there's a lot of tooling that you can tap in with Kubeflow as well. If you're not thinking, oh, that's all good in practice, sounds really good, Kubeflow, I want to give it a shot. How does it look like in practice? Should my enterprise start using it? Well, I got the case study for you that you can kind of check into how people are actually using this in production, which is Shell. So for a reason, I left the keynote name there, because if you want to learn more, you can actually search it up there. I will actually link it, give you the link at the resources portion of this talk as well, but you can see it already here. So Shell, big enterprise, as you know, they had ambitious goals and they really needed machine learning to meet those goals. But they faced some challenges in the beginning. So they faced the challenge of disparate and inconsistent dev environments. So creating proper dev environments was tricky. So using local data might have been easier, but using large sets of data from global sources really provided a challenge for them. They also had the requirements for a lot of specialized skills. So because running these environments requires specific skill sets, and anything to do with Kubernetes is going to require a lot of knowledge as well. So you have to consider this. Then also going back to the cost topic a bit. So they also faced this challenge of wasted and underutilized resources. So as they actually said it in the keynote as well, like we cannot bankrupt the company. So you have to consider these resources and the models that you're using, because the modeling phase in particular uses a lot of computational power. So not just, so you really do need to consider these things. So Kubeflow helped them solve these things by providing a secure cloud hosting and self-service model. So they could do rapid onboarding and scale. They could do self-service model with data scientists can grab computational power and use pre-configured settings. And it what used to take weeks or months of them now just takes minutes. Kubeflow automated pipelines engine Kale also helped them as well. So easily turns then notebook code into scalable pipeline so much faster there. Shared cloud resources helped as well. So you can accelerate model training and deployment with it. And you can monitor the notebook servers, so see how much compute they're using, as well as then release the compute if needed. So that's a great case study that you can kind of look into deeper on if you want to learn more there. Then a bit more about best practices that you can think about when you're doing this. And now we're going to go, let's see where we go. And we're going to go to the mountains, because best practice, there's a lot to learn from there as well. So best practices, some of these things. Master all the skill sets and necessary skills. And then this is kind of a very easy caveat, whatever you're doing something, master the skills that are needed to do it. But I think in the machine learning and AI field in particular, it is actually, it is simple, but also not as simple as it looks like. Because as I said, there's so many different skills that are related to it, so many different fields, so much interdisciplinary collaboration. So if you're coming to machine learning, AI, machine learning operations from a data scientist background, for example, you will have to probably learn more about CLIs, Cloud Shell development, Linux command line, Bash shells and commands, and cloud computing foundations and so forth. So you really have to kind of dive deep into their like source control and so forth. But if you're actually coming from a cloud native or DevOps or machine operations background, then you might actually have to dive deeper into Python or math, because, descriptive statistics, normal distributions optimization might be something that you need to kind of brush up on, or just generally the data science way of doing things also might be something that you need to consider. So there's a lot to do there. But it really does start with data, though. If your data is not good, you're going to be kind of going wrong from the get-go. So it is all built, if you're building a machine learning model, but the underlying data wouldn't be good, you're going to be not ending in a good result anyhow. So that's all the base for everything. As always, with all operations tooling, it's really important to know your tools and that you need and choose them wisely from there. So you have a host of things that you can select them, but you are the expert in your infrastructure and probably know the best, or you can obviously get help from consulting or professional service companies to get started here. And in this space, for example, you have the cloud native machine learning platforms such as AWS SageMaker, Azure ML Studio, GCP AI. You might also have to think about platform containerized workflows, so Kubernetes, Docker, serverless technology, just as Lambda, Azure Functions, Google Cloud Functions, all of these. And then there's also specialized hardware for machine learning, as well as big data platforms such as Databricks, Spark, Snowflake, and so much more. You also have to think about the bottlenecks that you face. So I spoke a bit more before about the fact that only over 50% of the models never make it to production. You really have to think about where are the different bottlenecks that your machine learning operations or machine learning is facing, and think about how to solve these. And then, honestly, MLOps loves DevOps. So if you're struggling to find good practices just for MLOps, maybe you can tap into DevOps practices. And honestly, it should be, as I said at the beginning, the foundation of all the MLOps works that you do is DevOps best practices that you can tap into there. You can consider serverless as well. So serverless might help you out in a lot of cases, but it is obviously depends on your exact needs and requirements. And a lot of the stuff that DevOps brings is obviously the basics of CI/CD, microservices, infrastructure as code, and really doing monitoring and instrumentation really well, as well as effective technical communication and effective technical project management as well. You might have to look into AutoML and Kaizen as well. Then, hopping back to our pirate map to considerations, and you might have guessed it, yes, this is where we get to the skull part, because we're going to be talking to some ethical considerations, because those are incredibly important in the machine learning and AI space. And some of the things that you have to consider and think about are, for example, fairness and bias. So developers must really address the bias in data and algorithms to ensure fairness in AI and ML systems. So biased data can lead to discriminatory outcomes, as well as reinforce existing inequalities. You have to also regularly audit data for bias, implement bias mitigation techniques, and strive for diversity and representativeness in the training datasets. You have to also consider transparency. So you have to take transparency seriously, and you have to also think about the fact that it is critical to building trust in AI system. So users and stakeholders should understand how AI decisions are made. So you should take some action by, documenting model architectures, data sources, and decision-making processes, and implement explainability techniques and to make AI models more interpretable there. Then you have to think about privacy, because you have to respect the user privacy by protecting sensitive data. AI systems must adhere to privacy regulations and best practices as well. And some of the actions that you can take there are to implement data anonymization, consent mechanisms, and data access controls to protect user privacy, comply with GDPR, HIPAA, all the required regulations. Then accountability is a big one. So you have to consider these things, and you have to ensure that the AI systems are accountable for their actions. So you have to understand who is responsible for AI decisions is crucial. And you have to establish clear accountability frameworks, conduct regular audits, and document the roles and responsibilities of AI system owners as well as operators. Consent and user empowerment is super important as well. So users should have control over the interactions with AI systems. So obtaining informed consent and providing options for user empowerment are important as well. So you should really clearly communicate the capabilities and limitations of AI systems to users. offer opt-in, opt-out features and user-friendly interfaces. Security, always important, but also in traditional engineering, but in this as well. So you have to consider security. So vulnerabilities in AI systems can lead to data breaches as well as misuse. So protecting AI systems against threats is essential. So you have to implement robust security measures, including access controls, encryption, and irregular security assessment to safeguard AI systems as well. You should focus into human-centric design as well. So you should consider prioritizing human well-being, or not consider, always prioritize human well-being and safety when designing AI systems, and involve then multidisciplinary teams, including ethicists and domain experts, into your decision-making process. Think about data governance as well. So developers should really establish their responsible data governance practices. Data should be collected, stored, and used ethically as well as securely. Long-term consequences. I'm getting tongue-tied here all the way. But long-term consequences, you really do have to consider them as well. So societal and environmental consequences of AI technology. So you have to predict these and try to mitigate them before the issues happen. There's also regulatory compliance that you have to really consider, obviously. So you must adhere to the applicable laws and all of the regulations as well. So stay informed with the evolving regulation, because the regulation is evolving a lot. And then how to kind of tap into these things as well. So that's it for most of the stuff. Now we're going to do some resources, going through some resources. So as always, you can find my links and slides from GitHub, from my folder there called presentations. And I highly recommend, by the way, this book, Practical MLOps by Noah and Alfredo. So if you're, after this session, you're thinking, I wish you had some more code snippets, more actual practical, like how to do things in Azure or AWS or whatever, one of these toolings, then I think the Practical MLOps book will have a lot of resources that you can kind of tap into and look through. Also, the keynote that I mentioned by Shell is linked there, which is the machine learning and Kubernetes made easy with Kubeflow. And then also, if you're looking into how does Kubeflow work, there's, for example, this Kubeflow for machine learning, where a Netflix engineer goes through some of the practices that they use there. Then we have a webinar there that I'm linking for MLOps automation with Git-based CI/CD for ML. So this is part of the CNCF webinar series that then goes a bit more deeper into serverless, Git, CI/CD with machine learning, and doing that, checking out that is really interesting. And then KubeCon has a co-located event called Kubernetes AI Day. So much wealth of knowledge there. Highly recommend checking those out. I'm linking here to the Welcome Plus opening remarks of one of the latest Kubernetes AI Days. The state of production of MLOps in Cloud Native was actually very, very interesting, and I actually really enjoyed this session. So looking into that might be super beneficial as well. But a lot to learn, a lot to deep dive even after this as well. So that's it for our agenda. Essentially, we are now going to be reaping the benefits, and we're going to take our little robot and travel to the end here. And as you can see, there we are. We are at the X, at the treasure, at the X marks the spot. So there we go, a bit of a zoomed in view so that we see here, and our robot made it there. Yay, we can congratulate ourselves. And what do we get as a reward? We get that reward. So we get to learn how to do scalable and reproducible generative AI workflows with Kubernetes, which is obviously, hopefully, something that everyone can deep dive and have fun with in the future as well. But that's it, mostly from my side. Here is a fun little image on how to confuse machine learning. Fun fact though, this has been solved a long time ago and very fast. So actually machine learning is not confused by this image most of the time at all, but it is funny. And I think they are actually similar to chihuahuas and muffins. What could be more fun? But that's it from my side. Thank you everyone for listening in. Thank you everyone for learning with me. You can always reach out to me for questions or comments. You can see my handle there. You can use that same handle across, essentially LinkedIn, Blue Sky, Twitter, all of the platforms essentially. So thank you everyone for listening. It's been fun.